Hey there, we're going to move ahead here and keep working on these equations. We now have variables on both sides of the equal sign. So we have a little bit of extra work to do, but totally stuff we're ready for. What we have to do is decide that we want to move all the variables to one side or the other. At some point, if you've done some of these, somebody may have said, oh, you move it to the left. Well, it really doesn't matter. So you want to think about, do I want to subtract 7x and make this negative 4x plus 7 equals negative 5, which is no big deal, except for the fact that it's negative. Subtract the 7, because that's how the additive inverse to get rid of that. So now I have negative 4x equals negative 12, which is super awesome. Right? The additive or the multiplicative inverse, right? So that's very technical for saying that these are being multiplied, so you're going to divide by negative 4. So x turns out to be 3. You can always plug that 3 back in both places to double check. We do more of that in Algebra 2 with some quadratics and more complicated equations, but it is totally a way to check this. All right, so your steps right there in your notes. Move variables to one side, right? I'm not going to force you to do this to the left or to the right. Just make a smart decision. Okay, so in the first time, I just went ahead and moved it to the left. Not the best decision because then I had that extra negative to deal with. So if you can avoid that, we're going to avoid it. So I'm going to do that here by moving 3r. So 5 equals 2r minus 19. I'm going to add 19 because that's how I get rid of subtracting 19. So I'm the whole way up to 24 equals 2r. Divide by 2. Sometimes I turn into a pirate. And if I divide by 2, because these were being multiplied, that means you end up with 12. We end up with a solution, okay? So move the constant to the opposite side of where we're talking about. That's why I moved 19, because I had all the variables onto the right, all the constants went to the left, and then we can divide as needed. So very basic steps, but they'll get you out of jam if you forget or something's going on there. All right, so do I want to make sure the variable becomes a bunch of negative or a bunch of positive? Well, I like to work with the positive. Okay, hopefully we spend enough time together, you know that I try and be a positive person because life's hard enough. Why drag it out and be negative about it? All right, so here we go, 14y, and now it equals 13. I'm going to add 15 because this, although we're adding, it's a negative. So to get rid of negative 15, I have to add 15. So 14y now equals 28. Isn't that nice, right? Because that would be 14 doubled. And say that double part all the time. The kids love playing with doubles. They're products of a math teacher. Sorry. 14 doubled. Oh, okay. And then we double that. Oh, that's 56. Okay. So that's cool. All right, the steps that we take. So this one's just a quick little review on some of that vocabulary we talked about. So in these, it looks like that was distributed. Okay, so that was distributive property. I guess we don't need property each and every time. What do we do next? We had 6u and we subtracted 6u, so that's an inverse property. So just reviewing those properties. So 6u minus 6u. Okay, so that's just going to be, it went into 16 became 10. So we're just going to call this substitution because nothing really happened there. It was the product of the inverse. Next thing we're going to do is we have 4 and we're going to subtract 4 to both sides. So again, that's an inverse. And then we ended up with a product of that. So that's a substitution because negative 21 minus 4 is negative 25. And then we're going to divide by 10. So that's an inverse. This one's by multiplication. So if I say that these were by addition, and that works. And then we're to a substitution to get negative 2.5. Okay, this one seems a little bit funny because we're writing that minus 6 horizontally instead of vertically. And what I mean is down here, I put it underneath instead of continued on there. And here it was underneath. So don't let that confuse you as we work left to right. Oh no, it's a fraction. What do I do? Delete it, delete it. We can't delete it. It's the same idea. Do you want to subtract 2/3 v? No, let's add 2/3 v. Okay. And this isn't too bad, right? Because they already have a common denominator. So now we're at 4/3 v minus 6 equals 6. Well, that's not too bad. If it's minus 6, we're going to add 6. So we're at 4/3 v equals 12. All right, how do we get rid of 4/3 v? Now, technically, you'd say I want to divide by 4/3. But we're not really going to do that because we're algebra kids. We're in high school now. Okay, so if I divide by a fraction, I actually have to multiply by its reciprocal, right? Because this would give me 12/12, so it's gone. 3/4. And to make this super easy to work with, I'm going to go ahead and put the 12/1. Okay, so I can either work this way and say 12 times 3 is 36, 1 times 4 is 4, and do 36 divided by 4 to get 9. Or option number 2 is say 12 divided by 4 is 3, and 4 divided by 4 is 1, so that would give me 9/1 right away. Either way, we have to end up with v equals 9. So that's how we deal with some of those fractions. All right, your other option, okay, so notice here that all of my denominators are 8 and 8 for the x's, so we can continue the same way we did before in 2 and 2 here. Or if I want to eliminate all the fractions, which some kids are really big fans of, let's just multiply the whole thing by what your common denominator would be. If I had 8 and 2, common denominator would be 8. So I'm going to distribute that the whole way through because I want this to be a strategy that you're comfortable with. So 8 times a half is 4. Right? 8 times 5 is 40. Divided by 8 is 5, so 5x. So in other words, these 8s are just going to cancel out. So that helps me identify the next one is just 7x. And 8 times 7 is 56. If I take half of that, or we can do this a little bit easier and say 8 divided by 2 is 4, so 4 times 7 is 28. Look at that, we got rid of all the fractions. Okay, so we call this first step, clearing the fractions. So that's an option that we have. And then we're just going to solve like you've been doing, because now it looks like a super duper simple one. At least I hope by now you find it pretty simple. We're going to move all the variables. I'm trying to make everything positive. So I get 12x plus 28. And then we're just going to subtract that 28. I don't have a choice here. We're going to have to make things a little negative. That's just the way it is. All right, so x turns out to be -2. So that gets our variables on both sides. How are we going to use some of that? Some of that number theory we talked about before. Okay, 5 times the sum of a number and 3 is, so that's an equal sign. So 5 times the sum, so 5 times the sum of a number and 3. Sum means addition, right? A number and 3 is the same as 3 multiplied by 1 less than twice the number. 1 less than twice the number, right? Less than, that's a switch, right? It means we have to put it in the other order. Okay, so I tried to underline and circle some things to build that equation. So it's 5 times the sum. It's 3 multiplied by 1 less than. So that means we have to add all these parentheses. So let me move my equation down here. 5x plus 3, 2x minus 1. All right, now I don't have any fractions, but I have a lot of extra distributing to do, and we're going to have to do that. So here we go, 5x plus 15. Make sure that turns into 15. 6x minus 3. Make sure that turns into 3. Which way you want to go? Do we want to move 6x and make it -1, or move 5x and make it +1? All right, positive. Let's do this. Minus 5x minus 5x. 15 equals x, or 1x minus 3. Add that 3. X is 18. Pretty good, pretty good. Right, so that's how we use it in our number theory. What else do we have? Ooh, consecutive even integers. Nice. Okay, so tripling the greater of 2. All right, well, I'm not even going to get it to that point. How do I set up consecutive even integers? The first number, I don't know. The next number, right, even integers, 2 to 4. So that's an x plus 2. All right, so this is our setup. Tripling the greater. Which one has to be greater? Something plus 2, right? So I have to triple the greater gives the same result as subtracting 10 from the lesser integer. What are the integers? All right, so make sure in the end I have 2 answers, right? We're going to find out x, Then we'd add 2 to that. 3x here plus 6, x minus 10. From here, you guys should be able to go and solve this thing and get our 2 answers. I'll go ahead and finish it out. I'm going to subtract 1x, right? That's 1x. That we don't get mixed up. 2x plus 6 equals negative 10 minus the 6. 2x, you are negative 16. Uh-oh, it's negative. Is that okay? It sure is. What word up here says it's okay to be negative? Integer. Okay, so that means the numbers are negative 8. And if I add 2, negative 6. Okay, make sure I answer both parts of that. And that's just from plugging it into our first and second right here. All right, perimeter. So we've talked about these. And we'll continue to talk about them. So right here we have length and width. That's good. So what we're looking for is where are they compared? Okay, a rectangle has a perimeter of 24. Okay, so P is 24. Find its dimensions. All right, so I need length and width. If the length is 3 inches greater than the width, all right, width's on the end, your x. Width equals x. Length, how do I say 3 inches greater than x? X plus 3. That's awesome. All right, so we can use the formula. What I find is kids really like to use a picture. Okay, so anytime we can, we're going to do that. For sure, I can plug it into this formula up here, and I will get exactly the same thing. But when I see this picture of perimeter, I get 1, 2, 3, 4. I get 4x. 3 and 3 make 6. And the perimeter has to be 24. Now I'm ready to solve it. All right, so let's get rid of 6. That's, what, 18 now? Divide by 4. X came out to be 4.5. Okay, so if the width is 4.5, plus 3 is 7.5 for the length. Okay, so this is where I go back so I can identify the answer by just plugging in x right here. So I just add 3 to it. All right, but most important is that comparison sentence right here that we started with. Okay, we're going to start on the end. That's x, 3 inches greater. That's x plus 3. All right, so we get some homework attached onto this one. And we can get started with those if you're comfortable with the lesson.